repeats can be dispersed throughout the genome, or they can be in tandem all together. So you can imagine there is a blue repeat and it's dispersed like here, here, and here on 2 different chromosomes, 3 different restriction fragments, or they could be in tandem sitting right next to one another, one after the other. So now what happens if I were to take genomic DNA containing these repeats, digest it with a restriction enzyme and do a southern blot. So I'm going to digest with EcoR1, and then I'm going to probe it in a southern blot. So, mini satellites take these repeated DNA, and we're going to plot it. Short sequence of DNA repeated many times, and we're going to probe it with a particular probe. So here is the DNA. Here is the marker. 1, 2, 3, 4, 5, 6, 7, 8. Here is the DNA that's been digested. You get a fragment of 6 kb, a fragment of 5 kb, a fragment of 4 kb, a fragment of 3, fragment of 2, fragment of 1, and a fragment of 1. So you get all these different types. Now, I'm going to probe it with a specific probe. So this is what the DNA actually looks like. This 6 kb fragment here is this 6 kb fragment here. It's got one copy of the repeat right here. This 5 kb fragment came from this 5 kb fragment here. It has no repeat. This 4 kb fragment has 3 repeats, all in tandem. This 3 kb fragment came from this fragment here with 1 repeat. The 2 kb has 1 fragment with 1 repeat. The 1 kb has no repeat, and the 0.5 kb has no repeat. You're going to blot it, transfer the gel, and then you're going to probe it with a probe that matches the repeat. So your probe this time is going to be specific for 1 repeat. So how many bands are going to light up on this gel? You're going to get 4. You're going to repeat will hybridize to this fragment, this fragment, and this. So you're going to end up with 4 different bands that will light up. Right? So your probe is the repeat, you're going to light up 4 different bands. Let's take the same gel, but now probe it with a probe that is not part of the repeat, but is part of this fragment here. The probe is sitting right here, not in the repeat, but outside of the repeat. How many bands will light up this time? 1. And what's the size of that fragment going to be? It's going to be 4 kb. So, all you're going to see is a single band. 4 kb. So the position of the probe is very important. If the probe is within a repeat, then you light up all the repeats in the genome. If the probe is in a fragment that contains the repeat but outside of the repeat, it will only pick up 1 fragment. It will only pick up that one that has it. So it depends on where your probe is. Any questions? You want to go through this again, or are you guys fine with this whole issue? Go over it again. So let's start with this individual here. Right? This is one single individual who's got 2 chromosomes and it's got these fragments of restriction sites. You're going to digest the DNA. You isolate DNA from this individual. You're going to digest it with EcoR1. And then you're going to take a probe that's going to match the repeats. That's going to be specific for the repeats. So when you run the gel is going to look like this for this individual. When you probe it with a probe that matches the repeat, you're going to light up. This probe is going to hybridize to this fragment here because it has 3 repeats. It's going to hybridize to this fragment here because it has 1 repeat. It's going to hybridize to this fragment here because where that repeat is present, that fragment will light up and fluoresce, or get radioactive, irrespective. And so you'll see a banding pattern that looks like. If on the other hand your probe, you have the same DNA, digested with the same restriction enzyme, but the location of the probe is different. The location of the probe is not within the repeat, the location